Hey everybody, today we're going to be doing some problems from the Unit 10 test review over area, volume of cross sections, and volume of shapes being rotated around an axis. So for number one, it says that we're going to identify the integral that represents the area of the region bounded by the graph y equals 4 minus x squared and this. So remember, when we're finding area of the curves, we just need to know which one is on top and which one is on bottom to be able to find the area. I also need to know where they're intersecting at. When I look at my answer choices, all of the limits are the same, so I obviously they gave me the intersections, so I just need to figure out what's on top. This is a parabola that is going down and up 4, so I know that that is a parabola that looks something like that. This is a linear equation that's crossing at -2 with a positive slope. So it looks like my parabola is going to be on the bottom. My parabola is going to be on the top. I said that backwards. So this is going to be the parabola minus the line. And none of my answer choices are that. They probably simplified this. So let's see if we can identify with that. It would be -x squared would be first, minus x. Remember to distribute your negative here, so 4 plus 2 will be 6. And that matches answer choice B. The base of a solid is the region in the first quadrant bounded by this line and the coordinate x-axis. What is the volume of the solid if every cross-section perpendicular to the y-axis is a square? So when it's perpendicular to the y-axis, that means everything, our limits and our equations, must be in terms of y. We must make sure everything's in terms of y. So, and also the square, we want to know that that shape, the area of the base is going to be s squared. So I need to know the side length here. So for this side length, I need to know which one's on the right and which one's on the left. Well, this is going to be the right graph because on the left it says was the coordinate axis. So my side length is going to be this minus 0. So that will be -2y plus 6 squared dy. My final step is just to get my limits. Well, I know that this should equal 0 if I'm looking at the y-axis. I know that x is 0, and I know that the y-axis is my border here. So, because if you want to rearrange this equation so it looks like the line that you're used to seeing, like if you subtract 6 and divide by -2, that will be -1/2 x plus 3. So you can see that's really just a line. It's just written solved for x because that's what we're going to need to use for our equation. So I'm going back to this equation to give you a little visual here. My graph here is at 3, and then I have a negative slope. It's bound by this and the coordinate axis, so meaning the x and y axis. So the reason I'm subtracting my side length here is from here to here. This line minus 0. This line minus 0. So to find my intersections, x is 0 here. I'm going to find what y equals here. So I'm going to subtract 6, divide by -2. Y is 3, which we knew that there. And my other limit, y limit, must be 0. So remember, we're going to write these in terms of y values. It goes from 0 to 3 on the y-axis. Those are my y coordinates. And then I have my right minus my left line, so this line minus 0 squared. Okay, so that's our equation. So to solve, I'm going to square this out first. So that's going to be 4y squared, because I can't do the integral without squaring this. -12 and -12 is -24y plus 36 dy. Okay, I'm ready to integrate now. I'm not sure if this would be considered a calculator or no calculator. We'll do it without a calculator because if it was a calculator problem, you could type it in right here, right? But we also got to know how to do it without a calculator. So I'll practice a little of both today, but let's do one by hand since we're at the beginning of the video. So I'm going to raise this by 1, y cubed. Raise this by 1 and divide by that. Raise this by 1, and we're going to evaluate it at 3 and 0. Okay, so now I'm going to plug in 3, and I'm going to plug in 0 and subtract those answers. So when I plug in 3, 3 cubed is 27. 27 divided by 3 is 9. 9 times 4 is 36. 3 squared is 9. 9 times 12, I'll come back to that. And 36 times 3. And when I plug in 0, you can see that's going to be zeros all the way across. All right, so when you do your math there, you get 36 minus 8, carry the 1, that's 108. 8, it's also 108. So you get 36. All right, number 3. I would say the setup is the most important thing because then you can do it without calculator, but you will have to be able to do a few where you actually plug them in and get the numbers. So be versatile and know how to do both. The area of the region bounded by the curve, the x-axis, the y-axis, and the line x equals 2. So let's kind of draw like a visual here. This graph is not super picturable. I know that it's like an exponential graph, but I'm not exactly sure what it looks. So I have the x-axis, the y-axis, and the line x equals 2 as a boundary. I know it's exponential, so it's probably sweeping up something like that. So it's probably in that zone right there. Again, this is just area, so really we just need to know as for sure if it's on top. And it should be on top compared to the y-axis. So for my limits, that should be easy because they gave this to us. 0 and 2 are my limits. Top curve is going to be this, minus bottom curve, which is just 0. All right, so that's exactly what I'm evaluating there. In order to evaluate this, if I don't get a calculator, this is going to require a u right here. My u is going to be 2x, which means I have a 2 that's going to pop out front. Well, a 1/2 that's going to pop out front when I do this because this is going to be dx. So remember, when I put this in place of here, I'm going to have a 1/2 that's going to come out front. So I have 1/2. When I integrate e to the u, it's just e to the u. So that's going to be e to the u, which is 2x. And we're going to evaluate that at 2 and 0. So when I plug in 2, I'm going to get e to the 4th. When I plug in 0, e to the 0 is just 1. Now it's just picking out which expression is correct based on this. So let's see. If I distribute that, I get that and that. Should be C. Number 4, let R be the region between the graphs of y equals 1. So there's y equals 1. Y equals sine x from 0 to pi over 2. So I know a sine kind of swoop-de-doos like that. From 0 to pi over 2. The volume of the solid obtained by revolving R around the x-axis is given by, so it's probably this little shape that I am revolving around the x-axis. Of course, I need to think about if my little hump is going to go up there or not. I would imagine this would be a calculator type problem so that you could see the visual of this. Now that I'm thinking about it, the 1 is probably going to be underneath. So it's probably going to more look like this. Here's 1. I shouldn't have done my swoop-de so high. There we go. It's probably more like that. Let's see. And if it's between 1 sine, ooh, it's this little space. The graph between 1 and sine from 0 to pi over 2. So there's going to be wherever that crosses. Okay. So I need to see what my r's are going to be for my formula. So from here to here is big R, like this distance. And from here to here is little r. I hope you can see that in my tiny little drawing there. I should have drawn it bigger. So my limits are from 0 to pi over 2. We know that for sure. Can we eliminate any answers? No. We know we're going to have a pi because it's rotating around the x-axis. Okay. For our big R, the top is 1 minus the bottom is 0. So that's big R. Minus little r. Little r is from the sine curve minus 0 squared. All right, maybe that will give us our answer choice. So this is just going to be a 1 minus sine squared. Yep, that's it. Guess it was doable without a calculator. Okay, number 5. The base of a solid is the region in the first quadrant. Enclosed by the graph of this, I see a parabola that is opening down at 2. I always like to get a visual for myself. First quadrant, it's up here at 2, going down. That's what a parabola looks like. And the coordinate axis. So it's telling us there's the shape. If every cross-section of the solid perpendicular to the y-axis is a square, the volume of the solid is given by. Okay, so again, we need the side length. Since it's perpendicular to the y-axis, that tells us that everything needs to be in terms of y because we're rotating. I'm sorry, because we're putting it perpendicular to the y-axis. So we should be able to easily get our y limits here. 0 and 2. Not those guys. Okay. And then I just need my s. So the distance from here to here is this, and this is where I need to rearrange it because it needs to be in terms of a y equation. So I'm going to solve for x. So y minus 2 multiply by negative 1 and square root it. Okay. So the volume is from 0 to 2. Those are my y's. From this line to 0. And I'm squaring it because it is a square, because this is this s squared dy. Okay, maybe one of those equations will make sense now. I know this square is going to cancel this square root, so it's really just negative y plus 2, which is the same thing as this. Okay, we have some kind of polynomial here. I see I have the same graph that I just drew, so I know what that one looks like. It's up here at 2, and I know it's going to be going down. This one is a little harder to picture. One thing you might want to do is to see if you can find the intersection points. It might help you figure out what it is. Another option is to factor this and to see if you can find where it crosses the x-axis. So there's some possibilities for you there. It's asking me for the points of intersection anyways, so I'm going to set them equal to each other and see if that works. I don't like how that is coming up. I think I might change my signs. I think I'm going to reroute this a little bit. Sometimes math is trial and error. I would like to multiply everything by -1 to see if my signs will work out a little better. So I'm going to say positive, negative, negative, positive. Let me try that. So I'm going to take out an x squared. Yeah, I like this better. Okay, because now, see, I'm getting a root here of 4. And I'm getting root here. Remember, if you factor the difference of squares, that's x plus 1 and x minus 1. So plus or minus 1 is another root here. So now I know that's where the x values are crossing. To get a coordinate, let's see. I know that they are crossing at when x is 4. Okay, but I don't know where in the y it's crossing at. So I'm going to plug that back in. So 16, 4 minus 16 is -12. So it's crossing at 4, -12. You could, by the way, plug it into either equation to find the point, because remember, this is the intersection points where these two graphs are crossing each other. So at 4, -12, no wonder they gave me a big graph. It's way down here. All right. At 1, 4 minus 1 is 3. So 1, 3 is another intersection. And when I plug in -1, that should also give me 3. Very interesting. I know this is a cubic graph, so my end behavior is going to be like up here and down here. So I know it's going to end up like that. So let's see. Just to get an ish of what this is going to look like. I know it's going to go there. I don't know exactly how far it's going to dip before it turns around. Really, I don't even need to know how high. Really, it looks like the only part I'm carrying is about like in between here. I also am looking at my parabola. I didn't quite draw it up high enough, did I? It's really going to be up here. Oh, that's going to make this make way more sense. Okay, we're making progress, guys. My parabola is like that. This graph is coming down like that. Okay. Really, the gist of it is I need this. Oh, and also this. How interesting. That's another piece that's intersecting. So if I'm looking for where I got a piece of intersection here and a piece of intersection here. Set up the integrals needed to find the area of the regions bounded by the two curves. Use the graphing capabilities to find the area bounded with curves. Oh, I was able to use a graphing calculator this whole time? Wow, I really struggled through that for no reason. I would have put that in the y equals, guys. Found my intersection points. Don't do all the work I just did. But now we learned a lot about how to find intersections here. Okay, so from -1 to 1, that's going to be one piece. So from -1 to 1, okay? I have the parabola looks to be on top in this area, and the cubic seems to be on the bottom. So the parabola is going to be g of x minus the cubic function. The main thing is you just need to know which one's on top. Okay, so that will give you the area of this little piece right here. Plus, if we want the area of this other piece, that's going to be from 1 to 4. And for this piece, you can see that the cubic function is on top. So f of x minus g of x.